Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry, and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry, and mathematics, then please do subscribe to my channel. So in my previous video, I had explained about the 10th chapter in 9th standard mathematics that was on Heron's formula. And from this video, we'll start the new chapter in 9th standard mathematics, that is 11th chapter, which is based on surface areas and volumes. So what do you mean by a surface area and what do you mean by volume? So in order to understand surface area, we can consider a square or a rectangle and we will consider a cube. So now we have a square and a cube or cuboid. So if you consider a two-dimensional image like this, so in this you don't have any volume, you just have the surface area. So now if we are considering a 3D object, then in order to find out the surface area, because surface area is only restricted to the surface of that particular object. Because it is only restricted to the surface of that object, you can only consider the two-dimensional parts of that particular object. For example, if you want to find out surface area of this cube, you have to open this cube so that you get 6 surfaces of this cube. So one will be on top, one will be in the bottom, one will be in the right side and one will be in the left side, and one will be in the front and one will be in the back. So total 6 squares or rectangles together will form a cuboid. So that means if you open this cuboid, all the surfaces what you can see will be rectangle in shape. So the area of each rectangle of that cuboid, that means basically each surface of that cuboid you should add up to calculate the total surface area of that cuboid. Similarly, this cuboid, since it is a three-dimensional object, so if you have a box, so box can be a good example for cuboid. So you can fill up that box with water or any other liquid or any other kind of material. So how much water or any other material that particular box can hold will be the volume of that particular box or cuboid. So if you're considering a box which is in the shape of cuboid, then how much amount of material it can contain within its boundaries can be known as volume of that particular object. So whether it might be a cuboid or whether it might be a cube or whether it might be a sphere or whether it might be a cone. So in this particular chapter we'll be learning about cone and various other three-dimensional objects. So the surface which you can experience of that object, so if you are calculating the area of that surface, then that is known as surface area, and the amount of material which that particular object can withhold in it, that is known as volume of that particular object. So now we have understood about surface area and we have understood about volume. So before moving into surface area, first we will look into cones. So in this particular chapter, especially we are looking into right circular cone. So what do you mean by right circular cone? So right circular cone means you have to consider a right angle triangle like this. So you have to consider a right angle triangle. So this right angle triangle, if you fold the one end of this right angle triangle and if you connect the other end of right angle triangle, so let's say if this is the base of the right angle triangle, so you're joining two ends of the base of that particular right angle triangle in order to form a cone like this. So in order to form a cone like this. So here the right angled triangle is curved in such a way the two ends of the base of that right angle triangle are meeting with each other. So that forms a right circular cone. So here if you want to calculate the surface area of this right circular cone, so that is the curved surface area of this right circular cone. What do you mean by curved surface area? The surface which has got curved can be known as curved surface area. If you consider the above part of the cone, so the above part of the cone also, if you cover it up with a circle like this, And if you're considering area of this circle, then it will be the total surface area of the entire cone. So now if we want to just calculate the surface, the curved surface of this cone, the area of the curved surface of this cone, then we should not consider the area of the circle which is getting formed on the top of cone. So we have to just the surface which has got curved, that is the right angle triangle which has got curved. So that surface area only we have to consider for curved surface area. So now in order to find out curved surface area of a particular right circular cone, here if you consider this as a cone, so let me draw a cone like this. So if you consider a cone like this, so now in order to find out the area of this curved surface, I'll consider the small portion of this curved surface. So I'll consider this small portion of curved surface, which will be almost straight line. Because if you consider a circle like this, so if you consider a circle like this, if you just focus on the small portion of this circle, so this small portion act as straight line. So this small portion we can assume this as straight line. So assume this as straight line because we are not considering the entire circular path what is there. We are just considering the small portion on that particular circumference of the circle. So similarly here also, when you bend a right angle triangle to form a right circular cone, so on the top of this cone, this circular shape what it is getting formed, I'm considering the smallest part of it, so which is almost a straight line. So from one end of this smallest portion, I'll just connect it to the base of the cone, and from other end of this surface, I'll just connect one more straight line like this. So here you can see there is a small triangle getting formed like this. So there is a small triangle getting formed like this. Similarly, if I consider another portion, another similar portion like this, so we have one more triangle. So like this, I can go on forming triangles like this. So here I can just go on forming small triangles like this. So when I go on forming small triangles, so in order to get the curved surface area, I can just add the areas of all these small triangles. So now this one we can call as B1, that is base 1 of first triangle. This we can call, so this particular length we can call as B2, that is the base of the second triangle. This particular portion we can call as B3, that is the base of the third triangle. This we can call as B4, that is the base of fourth triangle. Like that it goes on like this, B5, B6, B7, B8. Like this it goes on and it comes back to this particular position again. So we have so many small triangles with base B1, B2, B3, B4, B5, B6, B7, B8, like that. Now we have the area of each triangle. So area of first triangle. So let's consider area of first triangle. So area of first triangle is half base into height of that particular triangle. So half base into height of this first triangle. So what is the height of the triangle? Here you should not consider the height of the cone. You have to consider the height of the small triangle which we are considering. Because here let me clarify one more concept. So in a cone, if you are considering a cone like this, so in this cone there is height and there is slant length of this particular cone. So what do you mean by slant height and what do you mean by height of the cone? So if you are considering the center of this circle which is getting formed on top of cone, so from that center, if you draw a straight line to the base of the cone like this, so this acts as the height of the cone, that is h. Now, if you consider this particular length of the curved surface area, so the curved surface area's length, if you are considering, that is known as L. And this radius of this circle which is getting formed on top of cone, that you can keep as R. So h means height of the cone, L means it is the length of the slant height. So because the height has got slanted like this, so that's why it is known as slant height. So L you can call as slant height you can call as h, which is the height, actual height of the cone, and r you can call as radius of the circle on top of the cone. So now we will remember these parameters, that is h, L and r. Based on this here, now we have to write area for first triangle. So half base into height of the triangle we have to consider. So here if I write h, that will be accounted for the height of the cone. But here we are not taking height of the cone. Here we have to take height of the triangle. And what triangle we are considering? So triangle we are considering on the surface of this particular cone. So on the surface we are considering. So if this is the cone, so on this surface we are considering triangle. So now assume this is a cone like this. So this surface we are considering a triangle like this, small triangle like this. So what is the height of this triangle? That will be the slant height of the cone, because here I am considering triangle here on the curved surface, not from the center of the circle. I am considering on the curved surface of the cone the triangle. So because I'm considering that triangle, so the triangle is getting formed like this. So if this is a cone, so triangles are forming on this slant height like this. So because triangles are forming on the slant height of the cone, that's why I'm considering the slant height as the height of the triangle, height of those small triangles. So first triangle's height will be L, and all the triangles are lying on the same curved surface area like this. So that's why all the triangles will have height equal to L, but they have different bases. So that's why I'll call this as base 1, but L will be constant. That is length of the or the height of the triangle will be constant. Similarly, area of second triangle, so area of second triangle will be half B2, that is base 2 into L, because here we are considering B1, B2, B3, B4, B5, B6, B7, B8. So L is the height of this triangle. Height of all the triangles is equal to L only, but bases are varying. So now we have half B1 into L, half B2 into L. Similarly for third triangle, it will be half B3 into L. Similarly for fourth, it will be half B4 into L, and it goes on like this up to Bn. So now if you want to calculate the curved surface area of this cone, so if you have to calculate curved surface area of cone, then here you have to add the individual areas of all the triangle, that is half B1 into L plus half B2 into L plus half B3 into L, plus it goes on up to, let's say, N. So there are n triangles. Let's assume there are n triangles. So it will go up to nth triangle, that is half Bn into L. So in all these L is common. So in all this L is common. So you can just take, and 1 by 2 is also common. So you can take 1 by 2 into L common, and inside bracket you can write B1 plus B2 plus B3 up to Bn. You can write inside bracket. So now what is the value for this B1 plus B2 plus B3 plus up to Bn? So in order to calculate that, we have to revisit this image. So here you can see, starting from B1, again it is ending at B1. So that means here it is B1, B2. So here I'll just write one more time. So I'll just write this diagram one more time. So we have a cone like this. So here we are considering this portion as B1, this portion as B2, this portion as B3. So like this, it is going B4, B5, B6. So it is coming back to B1. So this last end will be Bn. So that means B1, B2, B3, B4, like that it is going on till Bn. So basically we are covering the circumference of the circle which is there on top of the cone. So because we are considering circumference of that particular circle which is there, on the top of cone. So if the radius of that circle which is there on top of the cone, if we consider that as r, so here we have considered that as r. So you can straight away take the circumference of the circle in the place of b1 plus b2 plus b3 plus up b4 up to plus bn. So that means here we are adding the individual part of that circle which is there on top of that particular cone. So half L into what is the circumference value? So circumference, we know that it is equal to 2 pi r. So now r is the radius of the circle which is there on top of the cone, and 2 pi is constant values. So L is the slant height of the cone. So here 2 and 2 gets cancelled with each other. So what will be remaining? Pi r into L will be remaining. So curved surface area is known as CSA. So CSA is equal to pi r L for a right circular cone. Similarly, now if you want to calculate the total surface area, so now if you are to calculate total surface area of this cone, that is known as TSA, that will be equal to curved surface area plus what area we have ignored here when we are taking curved surface area. The circle's area we have ignored because the circle which is getting formed on the cone is not curved. The right angle triangle which we have considered has got curved. So that's why it is known as curved surface area. But if we consider the area of circle on top of the cone also, then it will be the total surface area of that particular cone. So that means here CSA, that is curved surface area, plus pi r square. So pi r square is the area of circle. So area of circle. So now what is the value for CSA? That is pi rl plus pi r square. So here you can take pi r common in both. So here L will be remaining. So here pi r you have taken, one more r will be there. So L plus r. So that is pi r into L plus r is the total surface area of a particular right circular cone. So these two formulas you have to remember in order to solve the questions based on curved surface area and total surface area of cone. So now we will look into the example. So before going into example, now sometimes they might just give height of the cone. They'll not give L because in these formulas we have L and in this also we have L, because in both curved surface area and total surface area we have L. So sometimes they won't give you L, they'll just give radius and height of the cone. So if they give height of the cone, how to find out slant height L? So in order to find out that, here you can see in this diagram, or else we'll write a new diagram like this. So we'll write a new diagram. So in this new diagram, I am writing a right circular cone. So this is the center of this circle which is getting formed on top of cone. So I'll join this center to the tip of this cone like this. So this is the height of the cone. This is the length of the slant height of the cone. And this acts as radius of the cone. So here you can see there is a right angle triangle formed. So where L acts as hypotenuse, H and R acts as the other two sides of right angle triangle. So now you can use Pythagoras theorem in order to calculate the value for L or the value for H. So what is the Pythagoras rule for right angle triangle? So hypotenuse square will be equal to H square plus R square. So now if you want to find out L, you can take square root of H square plus R square. So you'll get the value for L. So this also you have to remember. So L value is square root of H square plus R square. Curved surface area is pi RL and total surface area is pi R into L plus R. So now we have all these values. Now we will move to the example questions which are there in this. So first we'll look into example 1. So in example 1, they have given radius of the circle and slant height of that cone. So you have to find out CSA, that is curved surface area of this right circular cone. So they have given L. So L is equal to 10 centimeter. and they have given a radius that is 7 centimeter. So directly they have given L, so no need to calculate L. So here no need to use this formula because they have already given L. Now you have to find out curved surface area of this right circular cone. So that is pi RL. So now pi value is 22 by 7. What is R? R is 7 centimeter. L is 10 centimeter. So here 7 and 7 gets cancelled with each other. So 220 centimeter square. Why centimeter square? Because this is 7 centimeter and this is 10 centimeter. So centimeter into centimeter will be centimeter square. So 220 centimeter square is the curved surface area of this right circular cone. So now we will move into the next example, that is example 2. So in example 2, they have given height of the cone. Here they have not given the L value, that is they have not given the slant height, they have given the actual height of the cone. So height of the cone is equal to 16 centimeter and base of the cone is equal to 12 centimeter, base radius of the base of the cone. So that is directly they have given R. So R is 12 centimeter. So now we have to find out curved surface area and total surface area both. So CSA is equal to pi R L. So here we don't have L. So this you can call as equation 1. So L is nothing but R square plus H square. So what is R square? R is 12. So 12 square plus H is 16. So 16 square. So now here you can't take 12 square value as 12 and 16 square root as 16. So you can't write this. You can't write this as 12 plus 16. This you should not do. Only if it is 12 square into 16 square, then you can write this as 12 into 16. You can take square root individually because 12 square into 16 square will be square root of 12 square into square root of 16 square. So you can split the square root for both of them. But here we have 12 square plus 16 square. So that means here you have to take the square of 12 and square of 16, add them together, whatever value you get, you should take square root of that particular value. So here first we have to calculate square of 12, that is 144, and square of 16, that is 16 6 are 96. So 96 plus 160 will be 256. So now you have to add 144 plus 256, that is nothing but 400. So 400 square root is 20 centimeter. So now L value is 20 centimeter. Now you can calculate CSA. Curved surface area is pi RL. So R they have given as 12 centimeter. So pi value is 3.14 into radius is 12 into length slant height we have got as 20 centimeter. So now you can solve this, and when you solve this you will get answer as 753.6 centimeter square. Now you have to find out total surface area. So total surface area is curved surface area plus pi r square. So what is curved surface area? Curved surface area is 753.6 plus pi r square, that is 3.14. R square means it is 12 square. So r is 12, so 12 square. So now it will be 753.6. So if you solve this, it will be 12 12s are 144. So 144 into 3.14 you have to do. So when you solve this, you will get 452.16. So if you add them together, you will get 1205.76 centimeter square. So now we will move to the next example, that is example 3. So in example 3, they have given a corn. So there is a corn like this. So which is in the shape of, approximately it is in the shape of cone, and you have lot of corn grains on this particular corn like this. So now you have to calculate how many corn grains are there on this corn. So here 1 centimeter square area of this corn has average 4 corn grains. So average 4 grains are there on 1 centimeter square of the corn area. So now if you calculate the curved surface area of this corn, and if you multiply that with 4, then you will get the total number of grains which are present on this corn. So in order to find out that, we have to calculate curved surface area, And here radius approximately they have given it as 2.1 centimeter. So 2.1 centimeter, and they have given the height of the cone. So height of the cone they have given, so that is equal to 20 centimeter. Now CSA, if you have to find out, you want L. So in order to find out L, you can take square root of r square plus h square. So here r square is 2.1 square plus h square is 20 square. So if you calculate this, you will get square root of 404.41. So now if you have to take square root of 404.41. So when you take square root of 404.41, it will be equal to 20.11 centimeter. So now we have got L as 20.11 centimeter. So now what is CSA? CSA is pi RL. So pi is 3.14. R we have calculated, R they have given as 2.1, and L we have calculated as 220.11. So here CSA is 3.142 into 2.1 into 20.11. So 3.142 into 2.1 into 20.11. So almost it is equal to 132.68. So almost it is equal to 132.68, or you can consider this as 132.7 centimeter square. Now you have to find out the total grains. So total grains is equal to, we don't know what is the value for total grains, that you can call as X. So 4 grains is there in 1 centimeter square. So total in 132.7 centimeter square, how much grains will be there? So that is the total grains. So you can cross multiply this. So X will be equal to 4 into 132.7 divided by 1 centimeter square. So here also centimeter square. So these 2 centimeter squares cancel with each other. So 132.7 into 4 will be equal to 530.8, or you can consider this as 531. So the total grains, is equal to 531 grains. So approximately 531 grains are there on this card. So this is all there in this particular video. After this, we have exercise 11.1. So that I'll be teaching in my next videos. Until then, if you want to learn more physics, chemistry, and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.